Welcome. Sorry. Let's solve Leetcode 2116. Check if a parentheses string can be valid. Okay, let's make this a little bit bigger so we can read it. All right, cool. A parentheses string is a non-empty string consisting of only open and closed parentheses. It is valid if any of the following conditions is true. All right, this thing is really long. I'm not going to read it, but basically, if you're if you have any experience coding, basically they want to know if all of the parentheses would be considered valid. Okay. One extra twist that they add is something about they provide a locked array or locked list. You're given a parentheses string s and a string locked, both of length n. Sorry, yeah, a locked string. Locked is a binary string consisting of only zeros and ones. For each index I of locked, locked I is 1, you cannot change s of I. But if locked I is 0, you can change si to either an opened or closed parentheses. Return true if you can make s a valid parentheses string. Otherwise, return false. Okay, let's go over this first example here. So the string is here, this s value, or here. So on the second row. And here's the locked string. So 0, 1, 0, 1, 0, 0. Again, so the ones mean that the string is not mutable. We can't change it. But if it's 0, we're allowed to manipulate the string at that index. Okay, so in this first example, we have this input s string and this locked this string as well. So because of this locked value at index 0 is 0, we can adjust this first index 0 of the string from a closing parentheses to an open, which makes these first indices 0 and 1 invalid. Moving on, indices 2 and 3 are already valid. There doesn't need to be any modification. However, for string at index 4 of string s, we have an issue because we have an open parentheses, whereas there would be no matching parentheses. However, because the fourth index of locked is 0, we're allowed to modify that current value at the string at index 4. So we can change this closing parentheses into an open one, and that just so happens to match with this string at index 5 or character at index 5, and so that this changed string of s or modified version of s is a valid string parentheses or parentheses string. So the return value is true. Okay, and for example 2, nothing is locked, but it just so happens that the string as it is perfectly valid. And for example 3, the return value is false because even though it's unlocked, it should be clear or obvious to us that one of the requirements for a valid parentheses string is to have an even length. So we'll be using that information in our solution today. Okay, I think that's enough for us to get started. I think this is just a twist on a pretty well-known problem where they just want to know if a string is a parentheses string is valid. The additional locked makes the problem more fun. Okay, so let's get started. Maybe we can move this out of, actually let's move out of the way for now. I'm trying to think if we want to, well, let's just go over something real quick. So let's get the length of this string. So we'll say n equals the length of s. And as we saw from example 3, if the length is odd, then we can automatically return false. So n And I like to use a bit operation here. So NN1, this will return. This is an easy check to check if n is odd. If it is odd, we return false. Okay, cool. So now we can move forward. So we know that at the very least, S is of even length. Okay, so I'm going to go over create two stacks here. Now the first stack will be for storing. So S will store hold. Let's see, stack of open parentheses. I think it's open parenthesis. I think it's like this. Parenthesis, indexes. So S will store all occurrences of an open parentheses. Let's put it in E, maybe with plural. I'm not sure if parentheses with a plural is an E or I. We'll leave it at E, and maybe that's a plural version. I'll have to add a comment for that. I'm not too certain. I think for singular, for sure, it's parentheses. Actually, I don't know. I'll have to Google that later. I apologize for not knowing that. Next, we'll have U will be a stack. We'll call these maybe like yeah, unlocked indexes. Okay, so that's what S and U will store. Now let's go over something here. Now suppose we have something like this. Suppose we have a string, this is our string, and like something like this. I don't know, it doesn't really matter, but suppose we have something like this. Let's say we have this. And these are all matched. Suppose these are all matched. Like these are all good to go. Sorry. Yeah, suppose, yeah, they're all matched. Let's make them match so it's easier to see. And then we encounter this thing here. So, and also suppose that our unlocked or locked, what do they call it, locked, looks something like this. So I'm going to actually just put it above it. So maybe these are all, it doesn't matter. Let's just say they're all locked. It doesn't matter. But over here, this is, let's suppose it's locked for now. It doesn't matter really. Okay. And so suppose we reach this point. So we have an open parentheses. And so far we have seen no unlocked indices or indexes. So we would have a problem because so we have a closing parentheses but nothing to match it with. So my point to you is we'll want to store where we see the unlocked parentheses for future use. So suppose we have something like this here. Suppose we have something like this. Let's say locked was, now suppose locked was something like, unlocked was something like this. Maybe it was in fact, yeah, let's do it like this. Let's do it like this better. Suppose this now first index is unlocked. And let's make it like this. So this is unlocked. Now suppose this now, it doesn't matter, but let's suppose it's locked. It's fine. Sure, let's suppose it's locked. Now we have something good here because we're at a point in our string where we have previously encountered or like a wildcard, something that we can manipulate. So my point to you is, as we loop through our string, we're going to store our unlocked indices because those are valuable. We don't know how we need them, but like we don't know if we're going to use them as an open or closed, but we want to like store them for future use. Okay, so let's so if we had this here, suppose we had this exact scenario, and once we have this, we can look back. Okay, so if we encounter like an invalid state, we if we can check if we have an unlocked index available. So in this case, we would, because we'll store this unlocked one. So when we encounter an invalid state, we can use it. So that's why we have this here. Okay, so let's kind of loop through our string and use this information as we search for a solution. So we can say for I in range n. So now let's store this. So we'll say if locked of I equals 0. So 0 means it's unlocked. Let's add it to our u.append. Let's add it to our stack of unlocked indices. So we'll say u_append.I. Okay, good. Now, otherwise, if we have, for example, if maybe s of I equals if it's open, if we encounter an open parentheses, remember s is, the purpose of the stack s is for storing open parentheses. So let's just do that. So if we see an open parentheses, we append it. So s.append I. Okay, and lastly, our last case or last scenario we're looking for is, well, once we reach this case, we know that this is locked, and we also know it's a closed parenthesis. So we know this. So once we get here, let me see, s of I is locked and a closed parenthesis. Let's just do this here. Okay, that works. Okay, cool. So now, what does it mean if it's locked? So and closing parentheses. So if this is a closing parentheses, so what we want though, if this is a closing parentheses, we want the stack to have the last element. We want there to be an element on the stack, and on this stack, that's an opening parentheses. So we can say, okay, if s, we can say s.pop. So hopefully that makes sense. So if we encounter a closing parenthesis, we check our open parentheses stack. Remember, this stack just stores open parentheses. And so if there's something on there, that means that this closing parentheses matches that perfectly. So that's very good. That's perfectly fine. Otherwise, suppose there is no element on the stack. Well, we need another way of figuring out what to do. But now suppose we have an unlocked previously seen. So we can use one of the indices, like, so for example, like if we're at index, I don't know, like 7. If we are at index 7, so remember if there's something on U, something in the U stack, that means that it must have occurred before 7. So we don't know what it is, but we can use it to match this closing parenthesis. So we can say, okay, great, I have something available. I'll have to go to my joker or wild card that I can change for anything for my purpose. I can do this here. Okay, great. So there's something that occurred earlier that I can change to match this closing parenthesis. Okay. Now notice though, it makes more sense to first check if the stack has an open parenthesis. Then we check if we have like a wild card that we can manipulate to match this closing parenthesis. Otherwise, well, what does that mean? So it means that we don't have anything to match this closing parenthesis. We don't have a wild card available to match this closing parenthesis. So that means we're just out of luck. So we can just return false there. Because there's nothing we can do to match this closing parenthesis. Okay. Okay, good. I hope that makes sense. Now, suppose now we've looped through this and we have, just suppose S looks like this. Just a bunch of open parentheses. So just suppose, remember, the sole purpose of S is to store open parentheses. Okay, so, well, we should also check if we have, at the end of this loop, what if we have some unlocked available that can match this? So, and remember those, S is not storing the actual parentheses, it's storing like the index of where this is found. So we can do something like this. We can say while S and U. Okay. So now, so let's go over this here. So we don't really have this anymore. We really have something like, what is it? Maybe, I don't know how to say it. Like 1, 4. These are indices of where those open parentheses are found. I don't know, 7 and 11. Just suppose this, and then suppose we have, let's suppose we have this here. Maybe U equals 0, 2, I don't know, 6, and I don't know, 9. So let's think about this here. So if this is an open parenthesis, remember this is an open parenthesis. We would need, what do we need? We need a closing parenthesis. Now this 0 occurs before the 1. So remember, we would need a closing parenthesis after it. We would need it after it. So we can say maybe, well, let's check this here. Maybe even this better. Let's look at this here. So this 11 is an open parenthesis. We would need this like wild card here. We would need this to occur after it. Now notice how 9 is not after 11. So then we would know this fails. So my point to you is this. While we're checking, we can do something like this. We can say and the last index of S occurs before the last index of U. Now if that's true, like suppose this was like 19. Just suppose, then this would be okay because somewhere down the road we had like it doesn't matter, it could be anything. We would have this wild card at index 19 that we could use to match this. So and we would. So at this point we can pop them both. So s dot pop and u dot pop. Okay, cool. Now, okay, so in this case, this would be true, right? So we could pop 11 and we could pop 19. Now, however, if we loop around again, we would see that 7 is not less than 6. So we need to count for that. So if we finish this loop and there's still elements on F's, so S, we return false. Otherwise, we return true and we're done. Okay, cool. So it looks like it's good when I check the local tests, or I don't know if they're local, but these test case they provided for us. Now let's submit it. Okay, looks pretty good. Let me take off these comments here. Maybe that'll help. But otherwise, I'm satisfied with the results. I think I'll leave these here. And, oh, we don't need this comment. I'll just take this off. And that's about it. I'll just submit it again, but I'm for the most part, I'm pleased with this result. Well, that's better. So I will probably add another video, but I think I'm gonna try solving this in C++, for those developers that use C++. Not everybody uses Python. In any case, if you found this video helpful or educational, please consider liking or subscribing, or both. Other than that, have a wonderful day. Take care of yourself. Cheers.